Hello out there, welcome to this tutorial on mensuration, and in this video we'll be looking at length of an arc and perimeter of sector of circles. Now we look at lines of a circle. Consider the circle center O, radius R, and this is another radius. The two radii here divide the circle into two sectors. So if you decide to separate them, like you have the minor sector and the major sector, we have the bigger sector as the major sector and the smaller sector as the minor sector. If we wish to deal with only one, that is the minor sector, we have it as center O of the circle. Name this point as A and this point as B. Then the curve here, which is called the arc, as L. Now we know that the length L subtends an angle theta at the center of the circle. So this is the center of the circle. The length of this arc subtends angle theta degrees, so that the length of the arc is given as L equal to theta over 360. Since this is just a fraction of a circle, that fraction we have here is theta, and since the total angle in a circle is 360 degrees, we have it as theta over 360, and the complete circle, we'll be talking about the circumference, and the circumference of a complete circle is 2 pi r. So the length is just a fraction of the circumference of the circle, which is represented in the formula here. Also, the perimeter of the sector is given as, in this case, to calculate the perimeter of the sector, we are looking at adding the side AO, OB, and the length of this arc. And AO is radius, also OB is radius. So we have two radii, which is going to be, the perimeter will be equal to 2R plus L, and we can still bring it together in a holistic way by saying theta over 362 pi r plus 2r, which gives the complete formula for the perimeter of the sector. Now from here we go ahead to solve some problems. Starting from problem 1. What is the length of an arc which subtends an angle of 100 degrees at the center of a circle of radius 21 centimeters? Take pi to be 22 over 7. To find the solution to this problem, we have the option of drawing the sector of the circle. So we start from the complete circle. This is the sector, subtends angle 100 degrees at the center, and the radius is 21 centimeters. So from the center to any part of the circumference is the radius. We have it as 21 centimeters. We are to calculate the length of this arc, the length of this minor arc. So we know that L equal to theta over 362 pi r, and our theta is 100 degrees over 360 multiplied by 2 multiplied by 22 over 7 times the radius, which is 21, and 0 cancels 0. From our calculator we can have it as 36.66666, and to 3 decimal places we leave it as 36.667 centimeters, which gives the length of this arc represented in the diagram shown here. Then we are done with problem 1. We go ahead to problem 2. For problem 2, the length of an arc 24.88 centimeters subtends angle 150 degrees at the center of the circle. Calculate the radius of the circle. We still take pi to be 22/7. Here we are given the length of the arc to be 24.88 and the angle of the sector 150 degrees. Apart from the pi, we don't know the radius. We are meant to calculate the radius. So you can see in this problem now we are not drawing or sketching the diagram. You have the option of bringing out the parameters as related to the problem, then look for the necessary formula and substitute in the parameters you get there. Now what we do here is we have the length of the arc to be theta over 360 times 2 pi r, and here our length of arc is given as 24.88. Theta is 150 degrees over 360 degrees, then multiply by 2 times 22/7, then times r. This is the r we are looking for. Straight away we can make r the subject of the formula. To make r the subject of the formula, here we have 24.88 multiplied by 360 multiplied by 7. We are multiplying by the denominators here. Apart from this, multiply by the denominators at the right hand side, then we now divide by the numerators. So we now divide by 150 times 2 times 22, and we press our calculator from here. So we have radius to be 9.4996 centimeters. And again, that is the end of solution to problem 2. We go to problem 3. For problem 3, what angle to the nearest degrees does an arc 12.5 centimeters subtend at the center of a circle of diameter 14 centimeters? We still take pi to be 22/7. We have a circle center O, and we are looking for the angle at the center. We know the length of the arc and the diameter of the circle, and the diameter of the circle is given, the radius is just divide the diameter by 2. That will give us the radius as 7 centimeters, and the length of this arc here is 12.5 centimeters. So from the formula of the length of the arc, we substitute these parameters we have in the diagram. We have the length of the arc to be 12.5 equal to theta over 360. We don't know the value of theta there. Then multiply by 2, multiply by 22/7, then times 7. So this 7 will cancel this 7. These are the numerators. So we have 12.5 is equal to 44 times theta over 360. Then we now make theta the subject of the relation. If we make the theta subject of the relation, we have 12.5 times 360 over 44, and that gives 102.2727 degrees from our calculator, and to the nearest degrees we have it as 102 degrees. And again, we have done justice to problem 3. We go to problem 4. For problem 4, calculate the perimeter of a sector of a circle of radius 3.5 centimeters if the angle of the sector is 125 degrees. Correct your answer to the nearest 0.1 centimeters. That's 1 decimal place. Take pi to be 22/7. From what we have already, This is angle 125 degrees, radius 3.5, and the length of the arc. To calculate the perimeter, we said it is 2r plus theta over 360 times 2 pi r, and our radius is 3.5. That's going to give us 7 over 2. That's multiplied by 7 over 2 plus 125 over 360 times 2 times 22 over 7 times 7 over 2. Here will give us 7. This is 7 here, the parts before the addition, and the addition is the connector. We have to simplify the multiplications first. All the multiplications are simplified. So 2 times 7 over 2 gives 7, and 125 over 360 times 2 times 22 over 7 times 7 over 2 gives 7.6389 from the calculator, and adding them we have 14.6389 centimeters, and we are to correct our answer to the nearest 0.1, that is 1 decimal place, which gives 14.6 centimeters. And we have done justice to problem 4, and this is the highest we can take in this tutorial. And please check the description section of this video on our YouTube channel to get the links to other mensuration problem. Our next video on mensuration regarding the sector of a circle is the area of sector and segment of circles. Remember to subscribe to our YouTube channel. If you love this video and it is beneficial to you, help us share it to others. Until I come your way again, goodbye. Hello out there, welcome to this tutorial on area of sector and segment of circles. If you are just joining us, check the description section of this video on our YouTube channel to get the first video on mensuration as regards to sector of circles. So here we go. Consider the sector of a circle, center O, radius r, and angle theta degrees. We wish to calculate the area of this sector. To calculate the area of this sector, that is sector AOB, it is given as theta over 360 and the topics specifies. Like from the topic, we are interested in calculating the area of the sector and segment of circles. We shall be creating the segments for us to see later, and how to go about calculating the area of the sector formed, the area of the segment formed. Here we said the area of the sector AOB, the entire area is given as theta over 360 times 2 is given as A equal to theta over 360 pi r squared. Remember, in our first video we said this sector is just a fraction of a circle. So the fraction is being represented by theta over 360 here, and since we know that the area of a circle is pi r squared, so we are multiplying it by the area of the entire circle to get the area of the sector. Now if you draw a chord from A to B, we discover that this section here, okay, let's shade it, this blue shaded part is the segment of the circle. Then how do we calculate the area of the segment of this circle? It is very simple. Like you can see, if you study it very well, we calculate the area of the sector, then calculate the area of the triangle AOB. Before you know what is happening, the subtraction will give us the area of the shaded part. The difference between the two areas will give us the area of the shaded part. So we just stated here that the area of the segment is area of the sector minus the area of the triangle. So we shall see how to go about this as we solve some problems on area of sector and segment of circles. So we take our first problem. Problem 1. Calculate the area of a sector of a circle of radius 7 centimeters, given that the angle the sector subtends at the center of the circle is 65 degrees. We take pi to be 22 over 7 again. Now, just from the formula we created, we have the sector of a circle center O, and the angle of the sector is 65 degrees, and the radius is 7 centimeters. Therefore, we say area of the formula for finding the area. Now, the formula for finding the area of a sector is given here. Now, we substitute in the parameters. We know the theta, we know the radius, and we know the pi. So we have area equal to 65 degrees over 360 times 22 over 7 times 7 over 1 times 7 over 1. The r squared here is this 7 times 7. And if we simplify from our calculator, we have 27.80556 squared centimeters. And that is the end of solution to problem 1. Since we are not given any degree of accuracy for our final answer, we leave it like this. So we go to problem 2. For problem 2, a sector of a circle of radius 15 centimeters whose angle is 118 degrees, it is cut off from the circle. Calculate correct to the nearest squared centimeters the area of the remaining part of the circle. We have the entire circle center O. This is radii. So we have our radii to divide the circle into sectors, and the radius, this small sector, the minor sector here, the angle of the minor sector is 118 degrees and the radius is 15 centimeters. We go through the question again. A sector of a circle of radius 15 centimeters whose angle is 118 degrees is cut off from the center, is cut off from the circle. Oh, this is cut off from the circle. But to calculate correct to the nearest square centimeter the area of the remaining part of the circle. Oh God. Now this is the area, this is the sector cut off. This is the part of the circle remaining, which we are going to calculate the area. So we need to calculate the theta, that is the angle this major sector subtends at the center of the circle. So our theta will be 360 degrees minus 118 degrees, which gives 242 degrees. And from there, we can now find the area of the remaining part of the circle to be 242 over 360 times 22 over 7 times 15 over 1 times 15 over 1. This is theta over 360 pi r squared. So from our calculator, we have it as 475.36 squared centimeters, and we are to correct our answer to the nearest squared centimeters. That gives 475 squared centimeters to the nearest squared centimeters. And we have done justice to problem 2. We go to problem 3. For problem 3, a sector of a circle has an area of 58/2/3 squared centimeters. If the radius of this circle is 8 centimeters, calculate the angle of the sector. Okay, here we are not calculating the area we are given the radius, and we are calculating the angle of the sector. So we have the sector angle theta. We call it theta, which is the parameter we are going to calculate here, and the radius is 8 centimeters, and the area of the sector is 28, and the area of the sector is 58/2/3 square centimeters. So from here we know our area of sector is theta over 360 pi r squared, and the area is given, so we express it as improper fraction, and that would be 58 times 3 plus 2. It gives 176/3, equal to theta over 360 times 22/7 times 8/1 times 8/1. That is r squared. Since our r is 8, so it's 8 times 8. We make theta the subject of the relation here. That is the numerator here, 176, multiplied by 360 times 7, multiplied by the denominator here, then divide by 3 times 22 times 8 times 8. From my calculator, I have it as 105 degrees. That is exact. It is exact. So 105 degrees is the angle of the sector. So we go ahead to problem 4. So the angle of the sector is 105 degrees. So we move ahead to the next problem. Problem 4, calculate the area of the shaded segment of a circle in the diagram below. Oh God, this is now the area of segment of circles. Now, we said the area of sector is, we said from the beginning of this tutorial that area of segment is area of sector, that is the sector AOB, minus area of triangle AOB, this triangle. The area of sector here is theta over 360 pi r squared. So I have my theta to be 70 over 360 times 22/7, that's the value of pi, times 6 times 6, then minus half r squared sine theta. That's the formula, half r squared sine theta. That will now give us half times 6/1 times 6/1, then sine 70 degrees. So pressing our calculator, I have 22 minus 18 sine 70 degrees is 0.9397. This is 20 minus 16.9146. From calculator, I have 18 times 0.9397 to give me 16.9146. Then finding this difference, I have 5.0 0.085 squared centimeters, which represent the area of this shaded segment of the circle. And that is the end of solution to problem 4. We go to problem 5. Calculate the area of the shaded segment in the diagram below. Leave your answer in terms of pi. This time around, we have to leave our answer in terms of pi. Again, since we are calculating the area of segment of a circle, we have to calculate the area of the sector AOB minus area of triangle AOB. So area of the segment is area of sector AOB minus area of triangle AOB. So it is necessary sometimes to label your diagram so that you can always make reference to it easily. So now the area of sector AOB is still theta over 360 pi r squared. So 120 over 360 times pi. Since we have to work with pi, then 6 times 6. This is going to give us then minus half sine minus half times 6 over 1 times 6 over 1 sine 120 degrees. So 6 times 6 here goes, we have 12 pi, then minus 18 times 0.8660, that is 36 divided by 2 gives 18, sine 120 gives 0.8660. So this is 12 pi minus 15.588. If you multiply out this, you get 15.588. Since we cannot simplify further, so we just put them in brackets, squared centimeters in terms of pi. So we just make it 4 significant figures. And this is the end of solution to problem 5. This is the end of this tutorial. I hope you enjoyed it. If you do, make sure you check the description section of this video on our YouTube channel to get the link to the first video on length of an arc and perimeter of sector of a circle. And remember to please help us share this video, subscribe to our YouTube channel. Until we come your way again, goodbye.